In this online lecture, we are going to learn about nucleophilic addition reaction. So let's look into the general mechanism. So this is addition reaction. Last time we studied about substitution. Substitution is about substituting, that means in place of something. But this will be adding. Okay, let's see how. So let's say we have the carbonyl group here, C double bond O in the form of this ketone here. Okay, so what will happen? Since this carbon is bonded to oxygen, which is electronegative, so this will be bearing partial negative charge and this will be slightly partial positive. So what will happen if there is a nucleophile, which is an electron-rich species in the vicinity of this carbonyl group? So what will happen? It will invite the attack of this nucleophile on this positive carbon, okay, partially positive carbon. So what will happen as a result of this nucleophile will go ahead and add here, okay. Then since carbon can form only 4 bonds, so this pi bond will be pushed over to the oxygen, giving it another lone pair, and this oxygen will bear negative charge. Now what will happen? So this oxygen from the vicinity, it will grab this H from the hydronium ion. This is H3O positive. Ion here, okay, 3 hydrogens and 1 oxygen. So what will happen, because this is electronegative, this shared pair of electron lies more towards the oxygen. He has more authority towards it, and this H will be slightly positive. So this oxygen will see this slightly positive hydrogen and immediately grab it towards itself, forming OH over here. And this is what we have, okay. So from ketone we get the alcohol here, and with the nucleophile added to this molecule. Now let's see some more examples. So let's look into some examples. Let's say you have this aldehyde group over here. Okay. So you have this carbonyl, and then you want to react it with Grignard's reagent. What is Grignard's reagent? It's CH3MgBr. Okay, and this is the first step. And in the second step, you're going to react it with the hydronium ion. Okay, so I'll go ahead and write first the products. What would be the products of this reaction? So there will be the OH group over here, and then there will be CH3 added here. Okay, the R group which is present here in the Grignard's reagent. Let's look into the mechanism of this one. So the mechanism, we have this aldehyde group over here, and then let's look into CH3MgBr. So what is CH3MgBr? So you do know that Mg bears +2 charge and Br bears -1 charge. So this methyl group should have -1 charge. So this is your nucleophile here. So what will happen? So from CH3MgBr, this will go ahead and make the attack. So I will write here CH3. Okay, this will go ahead and make the attack on this positive carbon. Okay, so you do know this is a partial positive charge over here, this carbon over here. It will invite the attack of the CH3, and what will happen as a result? This pi bond will be pushed to the oxygen, so we will have this thing. So you have O and this electron pair from the bond with negative charge, and you have this hydrogen here, and since this came, so the CH3 will be added here, right? So what is the next step? In second step, you will go ahead and react it with hydronium ion. So how do you have hydronium ion? So this is how your hydronium ion looks like, right? So what will happen? This oxygen will try to pull this electrons from this bond towards itself. So this hydrogen is pretty positive. It will invite the attack of this negative oxygen, right? So this is immediately looking for someone who can take the electrons, and this hydrogen is almost free. Okay, it is being pushed away because oxygen is taking this and trying to compensate its positive charge. So what will happen as a result? So you have this thing. So you will have OH group over here. This hydrogen is here and this CH3 here. Okay. So from aldehydes, you make alcohol. This is a secondary alcohol. Okay. In case you have formaldehyde, okay, that means you don't have the R group here, but just the the formaldehyde, only one carbon. Okay, then you will be able to form the primary alcohol. Okay, and if you have ketone like over here, then you'll be able to form the tertiary alcohol. Okay, like here. So this is tertiary alcohol, and then here if you start with the formaldehyde, then it will be your primary alcohol. Okay. Let's see what's next now. Now let's say we have this over here. So this is a cyclic ring. 1, 2, 3, 4, 5. So cyclopentanone we have over here, and we go ahead and react it with Grignard's reagent like we did with our previous example. So what do we have over here is this will be the product of this reaction over here. So we have Grignard's reagent, okay, and then in the second step we have this hydronium ion. We will react it with that. So you do know that your let's look into the mechanism. So this is your cyclopentanone, and we will go ahead and react with the CH3 because this is your nucleophile. So it will be attacking on this partially positive side, the carbon over here. So what you will have is this thing, this double bond will be pushed to the oxygen. So you have this O negative over here, and then you have this CH3. And in the next step, what it will do, it will go ahead and grab the hydrogen from this one, okay, from the solution. So this will be having this bond, and this O negative will immediately attack over here. So you have this thing, this O will become OH, and this is your CH3 over here, okay. Now let's look into some other reagents. So now we can do it with another reagent also, the reduction of ketone into alcohol. Then we can use sodium borohydrate. In the first step, we are going to react it with that, and then in the second step, as usual, we will go ahead and react it with the hydronium ion. So let's look into the mechanism, and then we'll write the product here. So we have this thing over here, okay, and then let's first look into our reagent, sodium borohydrate. So it looks like this, okay. So sodium is the one which is having the positive charge. This one has the negative charge. So boron with the four bonds, it bears negative charge. And out of boron and hydrogen, hydrogen is more electronegative. So I'll go ahead and write negative over here, and this is electropositive. So this is a negative. This negative is the overall charge. So we are talking about the partial positivity or negativity. We are talking about the polarization of this bond. So this is a different thing, and this is a different thing. So this hydrogen is partially negative. So this will be the electrophile which will go ahead and make the attack. So I will write here, or let's draw it. Let's draw any on this side. Okay, so this will go ahead and make the attack over here. Okay, let me draw it pretty close. Hydrogen and like this. Okay, so this boron uh, will be electropositive. Just 1 second. Yeah, and this will be making the attack over here. Okay, so what we will have, let's erase this part over here, and then what we have is this thing. Because of the attack, this bond will be pushed to the oxygen, and so we have this hydrogen attached over here, okay, and we have this O negative over here. So oxygen negative. So what will be the second step? You know that hydrogen and OH2. So this oxygen is bearing a positive charge. We will try to attract this pair of electron, and this oxygen will attack on this one. And what will be the result of that? There will be a OH bond here, and then you have this hydrogen over here. Okay. Um, so this is your final product. Okay. Now let's look into the other reagent. Okay. So if you have here this reagent, it is good to reduce your ketones, aldehydes, okay, even acid chlorides. But if you have ester in case, then this is not the reagent for you. You have another reagent which we are going to work on now. So for esters, we have to use lithium aluminum hydride. So what we will do here is this. Let's look into the mechanism, and first For doing that, we will look into the reagent. So lithium and then aluminum hydride is like this. Okay. So lithium is the one which is bearing the positive charge and the negative charge is on aluminum hydride. And then what will happen here? So aluminum has the negative charge, okay, and it's similar to the boron hydride, the example we just did. So what will happen? This hydrogen will go ahead and make the attack on this partial positive side. So this bond will be pushed to the oxygen. So this is what we have over here. Oxygen with the negative charge, okay, and then you have this OCH3 group, and then this hydrogen will be attached here. So what will happen next? So with the aldehydes and ketones, you can just add one hydrogen or the R group or the methyl group. So from CH3 MgBr, okay, the R group or the CH3 group can be only one can be added to aldehydes and ketones, and from sodium boron hydride, only one hydrogen can be added to aldehydes and ketones. However, with the acid chlorides and esters, you can do that twice. So let's look at into that. Let me erase this first, and then what's the next step? So in the next step, we will make the attack of the another hydrogen from here. So that one thing will happen. This oxygen will push down its electron, okay, and then this will be kicked out, okay. So let's go ahead and do that. So what we have is the double bond O here, and this is kicked out from here, and then we have this H over here, okay, on this hydrogen over here. Now what will happen? I'm gonna draw it here. Double bond O and then H, and then what we have is this one of the other hydrogen will make the attack on this carbon and carbon, okay. So let's say that this is let me redo it, just 1 second. Yeah, so this will go ahead and make an attack over here, forming and this will be pushed back over here. So oxygen with the negative charge, and this, there are two hydrogens now, okay. It would be the next step. So the next step would be the second step, to add the hydronium ion or the water. So this will be here the next step. This will grab this one, and this oxygen will grab this hydrogen. So here you have your alcohol with you, okay, with two hydrogens over here, okay. So this is how we can reduce ester into alcohol.